Hello everyone. In this lecture we are going to discussing about the how to solve the problem on angle of taper hole by ball and rollers method. Let's see the problem. Calculate the angle of taper and minimum diameter of an internal taper from the following readings. Diameter of bigger ball is 10.25 mm. Diameter of the smaller ball is 6.07 mm. Height of top surface of bigger ball from datum is 30.13 mm. Height of top surface of smaller ball from the datum is 10.08 mm. Here we have to determine the angle of the taper as well as the minimum diameter of the internal taper. Let's see the solution. In the previous lecture we derived the expression for angle of taper hole by two balls with the different diameters. That expression is sin theta by 2 equal to r2 minus r1 divided by h2 minus r2 minus of h1 minus r1. Here r2 is the radius of the bigger ball, that is given in data. Diameter of the bigger ball is 10.25 mm. Then the radius is the 5.125 mm. Similarly r1 is the radius of the smaller ball, that is given in data. Diameter 6.07 mm. Then the radius of the smaller ball is 3.035 mm. Similarly here h2 is the height of the top surface of bigger ball from the datum is 30.13 mm and h1 is the height of the top surface of smaller ball from the datum is 10.08 mm. Then we have to substitute these R2, R1, H2 and H1 values in the above equation. So we will get the theta equal to 13.36. So this is the first part we are finished. Then we have to determine the minimum diameter of the taper. So let us consider here. So minimum diameter of the taper hole, let us consider, that is the small d, and O is the center point. Next we have to draw a line from the O1 which is perpendicular to the inclined surface of the workpiece. So that is the intersect at point B. Here line O1B is perpendicular to the surface of the hole. So next we have to draw a horizontal line from O to O1. So next we have to draw a line from O which is parallel to the workpiece surface and it will be intersect at C for a line of the O1B. So it is the intersect at point C. Here we have to observe that one so triangle O1C0 is the right angle triangle with an angle of the theta by 2. So next we have to apply the trigonometry basics. Then we have to calculate the sin theta by 2. Then sin theta by 2 will equal to the O1C divided by the O1O. So next we have to see what is the value of the O1C. In the diagram we have to observe that one the O1C should be equal to the O1B minus CB. We know that one the O1B is nothing but radius of the smaller ball. So that is the D1 by 2. Similarly we have to observe that one the CB value is nothing but D by 2. Then O1C will become the D1 by 2 minus D by 2. So next we have to calculate the O1 value. So in the diagram we have to observe that one so H1 value is given, then we have to calculate the O1 to O. So O1O have to calculate, that is the H1, that is the height of the smaller roller surface to the datum point, that is the H1, minus it's a radius, it's nothing but minus D1 by 2. Then we have to substitute this O1C and O1O values in the above equation. Then we will get the sine theta by 2 equal to d1 by 2 minus d by 2 divided by h1 minus d. So in the diagram, in the data already given the d1 values and the h1 values, and also we are calculated the theta value also. Then I have to substitute all the values in the equation. Then we will get the sine theta value. We got that one, the 13.36 divided by 2. Sine 13.36 divided by equal to 3.035, that is the radius of the smaller ball, minus d by 2 divided by 10.08 minus 3.035. So then I have to solve this equation. We will get the d value is the 4.43 mm. Thank you.